Hello everyone, myself Joshi. Today we are going to study few more topics of complex numbers. So the first one is de Moivre's theorem. For any real number n, one of the value of cos theta plus I sin theta whole raised to n is cos n theta plus I sin n theta. Okay, that is cos theta plus I sin theta whole raised to n is written as cos n theta plus I sin n theta. Okay, so this we have to remember. Now similarly we have cos theta plus I sin theta whole raised to minus n. Now this we can write as e raised to I theta. Okay, so this is e raised to minus n I theta. So again we can write it as cos minus n theta plus I sin minus n theta. Now we know that cos is an even function and sin is an odd function. Okay, so cos of minus n theta is cos n theta and sin of minus n theta is minus sin n theta. Therefore cos theta plus I sin theta whole raised to minus n will give you cos n theta minus I sin n theta. Okay, now we have cos theta minus I sin theta whole raised to n. Okay, so this we can write as e raised to minus I theta whole raised to n, that is e raised to minus n into I theta. So this we can write as cos n theta minus I sin n theta. But we know that cos n theta minus I sin n theta is what? Cos theta plus I sin theta whole raised to minus n. Therefore we can say that cos theta minus I sin theta whole raised to n is equals to cos theta plus I sin theta whole raised to minus n. Alright, now if z is cos theta plus I sin theta, then 1 upon z will be 1 upon cos theta plus I sin theta. This we can write as cos theta plus I sin theta whole raised to minus 1. Okay, so using the previous formula, we can write this as cos theta minus I sin theta. Okay, now cos alpha plus I sin beta whole raised to n is not equal to cos n alpha plus I sin n beta. Okay, also sin theta plus I cos theta whole raised to n, this is not equal to sin n theta plus I cos n theta. Okay, these two we cannot write. Now, but this sin theta plus I cos theta whole raised to n, this we can simplify and we can find some answer. So this sin theta we can write as cos pi by 2 minus theta, and this cos theta we can write as sin pi by 2 minus theta. Okay, now we can apply the theorem. Okay, so this n will come over here, right? So you will get cos n pi by 2 minus theta plus I sin n pi by 2 minus theta. Take this n inside. Okay, so this will give you cos n pi by 2 minus n theta plus I sin n pi by 2 minus n theta. Alright, now we will find the nth root of a complex number. Okay, so z is equal to x plus iy. So nth root, that is z raised to 1 upon n, is what? X plus iy whole raised to 1 upon n. Now we will write this in the polar form. So in place of x we have to write r cos theta, in place of y we have to write r sin theta. Okay, so you will get z raised to 1 upon n as r we can take out common, so cos theta plus I sin theta whole raised to 1 upon n. Okay, bring this r outside, so this is r raised to 1 upon n cos theta plus I sin theta whole raised to 1 upon n. Now we will replace the theta by 2k pi plus theta. So here you will get z raised to 1 upon n as r raised to 1 upon n cos 2k pi plus theta plus I sin 2k pi plus theta whole raised to 1 upon n. Okay, now using the de Moivre's theorem, what we'll do, bring this 1 upon n over here. Okay, so what you will get, z raised to 1 upon n is equal to r raised to 1 upon n here cos 2k pi plus theta upon n plus I sin 2k pi plus theta upon n. Okay, so this result we will remember. Okay, now the values of k are from 0, 1, 2, 3 and so on. Okay, so let's substitute the value k is equal to 0 over here. Okay, so first root we are getting, we'll name it as a z0. Okay, So this is r raised to 1 upon n. Now in place of k substitute 0. So you will get cos theta upon n plus I sin theta upon n. Okay. Now let's substitute k is equal to 1. So you will get z1, that is r raised to 1 upon n into cos. Now here we have 2 pi plus theta upon n plus I sin 2 pi plus theta upon n. Okay. Now for k is equal to 2 we'll get z, that is r raised to 1 upon n cos. Here substitute 2, so you will get 4 pi plus theta upon n plus I sin 4 pi plus theta upon n, and so on. So at last substitute k is equal to n minus 1. Okay, so we will get z n minus 1, that is r raised to 1 upon n cos 2 times n minus 1 pi plus theta upon n plus I sin 2 times n minus 1 pi plus theta upon n. Okay, now let's solve few examples. Now show that if C is any nth root of unity other than unity itself, then 1 plus C plus C square plus up to C raised to n minus 1 is equal to 0. Okay, so now here Z is given 1. Now we will compare this with x plus iy. Okay, so x is 1, okay, and y is 0. Now we will write the polar form. So r is equal to under root x square plus y square. Okay, that is under root 1 square plus 0 square, right? So you will get answer of r as 1. Now x is greater than 0, y is greater than 0. Okay, so this lies in first quadrant, right? Therefore, theta is what? Tan inverse mod y by x. Okay, so let's substitute the value of y and x. Okay, so you will get tan inverse 0 and this is 0. Okay, so now this z we can write in the polar form is r cos theta plus I sin theta. Okay, r is 1 and theta is 0. Okay, so this z this is 1. Okay, this we can write as cos 0 plus I sin 0. Okay, now we have the formula z raised to 1 upon n is r raised to 1 upon n cos 2k pi plus theta upon n plus I sin 2k pi plus theta upon n. Okay, this is the formula, and k varies from 0, 1 to n minus 1. Okay, therefore 1 upon 1 raised to n is equal to here cos 2k pi theta is 0, so 2k pi upon n plus I sin 2k pi upon n. Okay, now the value of k is from 0, 1 up to n minus 1. Now for k is equal to 0, okay, substitute 0. So cos 0 plus I sin 0, okay, so you will get answer 1. Now for k is equal to 1, what will get? Here cos 2 pi upon n plus I sin 2 pi upon n. Okay, so this we can write as e raised to I 2 pi upon n. Okay, and let's give it a name c. Okay, now for k is equal to 2. Okay, what we will get over here? Cos 4 pi upon n plus I sin 4 pi upon n. Okay, so this we can write as e raised to I 4 pi upon n. Okay, so also this we can write as c square. Okay, because c is e raised to I 2 pi upon n. Now similarly for k is equal to n minus 1, okay, what we will get over here? This is cos 2 into n minus 1 pi upon n, okay, plus I sin here 2 into n minus 1 pi upon n, okay, and this we will write as c raised to n minus 1. Okay, now we will add all the terms. So this is 1 plus c square up to c raised to n minus 1. Okay, now this is a geometric series. Okay, and its sum is what? Sn is what? A into 1 minus r raised to n upon 1 minus r. A is the first term, that is 1, and r is the ratio, that is c. Okay, so using this formula, what we will get? This sum as 1 minus c raised to n upon 1 minus c. Okay, now it is given in the question that C is any nth root of unity. Okay, so 1 raised to 1 upon n is C, therefore C raised to n is what? 1. Okay, so C raised to n is 1, so this term is gone, so this answer is 0. Therefore, we have proved that 1 plus C square up to C raised to n minus 1 is equal to 0. Okay, now let's discuss one more example. If alpha and beta are the roots of the equation x square minus 2x plus 2 equal to 0, okay, we have to prove that alpha raised to n plus beta raised to n is equal to 2 raised to n by 2 plus 1 cos n pi by 4, okay, and from that we have to deduce that alpha raised to 8 plus beta raised to 8 is equal to 32. Okay, now the equation is given, that is x square minus 2x plus 2 is equal to 0. Okay, so firstly we'll find the roots. So x is what? Minus b plus or minus under root b square minus 4ac upon 2a. Okay, so here b is what? Minus 2, so you will get 2 over here plus or minus here 4 minus a is 1, c is 2. Okay, so you will get 8 upon 2. So this is 2 plus or minus under root minus 4 upon 2. So this is 2 plus or minus 2i upon 2. Okay, we can take out 2 common. So this is 1 plus or minus I. Okay, now here we have two roots. So let's keep name alpha as 1 plus I. Okay, and beta as 1 minus I. Okay, so now compare this with x plus iy. Okay, so x is 1, okay, and y is 1. So let's find r. R is under root x square plus 5 square, that is 1 square plus 1 square, that is under root 2. Okay, and x and y both are greater than 0. Okay, so this lies in first quadrant, right? Therefore theta will be tan inverse mod y by x. Okay, so this is equal to tan inverse mod 1 and this is y by 4. Okay, now this we can write in the exponential form as alpha is equal to r e raised to I theta, that is root 2 e raised to I pi by 4. Alright. Now beta is 1 minus I. Okay, so compare with x plus iy. So x is 1 and y is minus 1. So r is what? Under root x square plus y square. So 1 plus again 1. So answer is under root 2. Okay. Now x is greater than 0 and y is less than 0. Okay, so this lies in fourth quadrant. Okay, therefore the theta is what? Minus tan inverse mod y by x. Okay, let's substitute y and x, so you will get minus tan inverse mod 1. Okay, so again we know the tan inverse 1 is pi by 4, so final answer is minus pi by 4. So this beta we can write in the exponential form as under root 2 e raised to minus I pi by 4. Okay, now alpha is under root 2 e raised to I pi by 4. Okay, and beta is under root 2 e raised to minus I pi by 4. Okay, now we have to write alpha raised to n and beta raised to n. So alpha raised to n plus beta raised to n. So this is under root 2 e raised to I pi by 4 whole raised to n plus under root 2 e raised to minus I pi by 4 whole raised to n. Okay, from this we can take out under root 2 common. Okay, so under root 2 raised to n is outside. Here we have e raised to I n pi by 4 plus e raised to minus I n pi by 4. Alright. Now this we can write as 2 raised to n by 2. Okay, now this we can write as cos n pi by 4 plus I sin n pi by 4. Okay, plus now this term we can write as cos n pi by 4 minus I sin n pi by 4. Okay, so this two term will get cancelled. Okay, so we have over here 2 raised to n by 2 into 2 times cos n pi by 4. Okay, so this we can write as 2 raised to n by 2 plus 1 into cos n pi by 4. Okay, this is what we want to prove as alpha raised to n plus beta raised to n. Okay, Now from this result we have to find alpha raised to 8 plus beta raised to 8. So let's take n is equal to 8. Okay, so alpha raised to 8 plus beta raised to 8 is what? 2 raised to, now here 8 by 2, that is 4 plus 1. So here we have 2 raised to 5. Okay, and over here cos. Now substitute n 8. Okay, so 8 pi upon 4, so you will get cos 2 pi, and we know the answer of cos 2 pi is 1. Okay, and 2 raised to 5 is 32. Therefore alpha raised to 8 plus beta raised to 8 is what? 32. Okay, now let's solve one more example. Using De Moivre's formula, find all the roots of 8i raised to 1 upon 3 in the complex plane. Okay, so now here z is given, that is 8i. So compare it with x plus iy. So the answer of x is 0. Okay, and y is 8. So r is what? Under root x square plus y square. Okay, so under root of 0 square plus 8 square. Okay, so you will get answer of r as 8. Now both are positive, so it lies in first quadrant. So theta is what? Tan inverse mod y by x. So this is tan inverse infinite and 5 by 2. Okay. Now the nth root formula is z raised to 1 upon n is r raised to 1 upon n cos 2k pi plus theta upon n plus I sin 2k pi plus theta upon n. Okay, now here theta is pi by 2. Okay, n is 3. Okay, let's take n is equal to 3. R we know the value theta, no? Okay, so let's substitute all the values. So 8i whole raised to 1 upon 3 is equal to, r is 8, so 8 raised to 1 upon 3 here cos 2k pi plus pi by 2 upon n is 3. Okay, plus I sin 2k pi plus pi by 2 upon 3. Okay, let's simplify this. So 8i raised to 1 upon 3 is equal to what? This 8 we can write as 2 cube. Okay, so this answer is 2. And over here, take the LCM. So you will get 4k pi plus pi, okay, upon 6 plus I sin 4k pi plus pi upon 6. Okay, and on substituting the value of k is equal to 0, 1 and 2, we can get the roots of this 8i raised to 1 by 3. Okay, now let's solve one more example. Solve z square minus 5 plus I into z plus 8 plus I equal to 0. Okay, we have to just find the roots. So z is equal to what? Minus b plus or minus under root b square minus 4ac upon 2a. Okay. Now here b is what? Minus 5 plus I. Okay, so you will get plus 5 plus I over here plus or minus under root b square, that is 5 plus I whole square. Okay, and minus 4, a is 1 and c is what? 8 plus I. Okay, upon 2. Now let's simplify further. So this is 5 plus I plus or minus under root. Expand this. So this is 25 plus 10i plus I square minus 32 minus 4i. Okay, upon 2. So this is 5 plus I plus or minus under root. Now I square is minus 1. So 25 minus 1 minus 32. Okay, and here 10i minus 4i. So you will get 6i minus 8 upon 2. Okay, now let's solve further. Okay, so this is 5 plus I plus or minus. Now this minus 8, okay, we will write as 9i square plus 1, because answer of I square is what? Minus 1. So minus 9 plus 1 will give you minus 8. So this is under root 9i square plus 6i plus 1. Okay, and upon 2. Now so this is 5 plus I plus or minus. Now this is 3i plus 1 whole square formula. Okay, upon 2. So on simplification we will get 5 plus I plus or minus here 3i plus 1 upon 2. Okay, so we are getting two roots. Let's give one name alpha. Okay, so this is 5 plus I plus 3i plus 1 upon 2. Okay, add them. So 3i plus I, that is 4i plus 6 upon 2. Simplification, you will get 2i plus 3. Okay. Now another root is beta. Okay, in that we have to subtract. Okay, so this is 5 plus I minus 3i minus 1 upon 2. So I minus 3i, that is minus 2i, and 5 minus 1, so plus 4 upon 2. Okay, on further simplification we will get minus I plus 2 as beta. Okay, so these are the roots of a given equation. Okay, so I hope you have understood throughout the section. Thank you for watching.